Hey everybody, welcome to the video. Today we're going to be talking about AWS CloudFront. So what is a CDN? Well, in order for us to understand what it is, we have to know what caching is. The simplest way to put it is that it's when you store data closer to the user or client so that they don't have to make a request all the way to the primary data source. This helps decrease the network costs. Caching also enables content to be retrieved faster because an entire network round trip is not necessary, as we just mentioned. The first time the user makes a request, it goes to the origin, which is basically where the file is located. And then it stores it in the CloudFront edge location, which is the cache. All the following requests are going to the edge location and not to the origin. So what are origins? Basically, an origin is the final destination the user is trying to reach. It's basically where the file exists. It could be an S3 bucket, an EC2, a load balancer, etc. Custom origins are web servers. S3 is not a custom origin unless it is hosting a static website. Static websites on S3 don't work with HTTPS, but if you have it in a CloudFront distribution, that can be resolved. Custom origins allow you to configure the ports, SSL protocol version, and the origin protocols. Basically, it allows you to configure whether you want every request that's being made to be HTTP or HTTPS. Now, if the objective is to make sure that the only way to connect to custom origins is from the edge location, then the way to achieve this is to use a custom header. You specify the custom header when creating the custom origin. The custom origin will be inserted from the edge location, and the origin will only allow the connection if the custom header is there. Another way, which is not represented by the diagram, is to configure a firewall to allow a list of public IPs for the edge locations. If we want to accomplish the same thing for S3 origins, we can block all user access to the S3 bucket from URLs other than the CloudFront URL. And the way to do this is by creating a special CloudFront user called the Origin Access Identity. You then give the Origin Access Identity a permission to read the files in your bucket. Then you update the bucket policy to block all requests except the Origin Access Identity. Now, to understand what signed URLs are, let's say that you have a content streaming app where you have users who pay a monthly subscription to stream the content. If you want to make sure that the users who are not paying, meaning the users who aren't subscribed, are not able to get to the content, and you want to make sure that it is exclusively available to the paid users, you create a signed URL or signed cookie that has an expiration date. The code in your application must generate the signed URL. You can think of behaviors in CloudFront as what settings you want in place when a certain path in your CloudFront distribution is requested. It can be a path such as *.css. When you define a behavior, you can configure a number of things such as TTL, which we will discuss shortly, the protocols, meaning whether you only want that path to be accessed using HTTPS or not. Or you could restrict access so that only accounts you specify that are able to generate signed URLs or signed cookies can access the content for the specified behavior. Now, anytime an object, such as a JPEG or a video, is requested by the user, the object will be taken from the cache or the edge location and not from the origin for up to 24 hours. This is the default. This could be a problem if the object gets updated frequently. For example, you had an old file like a video or a JPEG and you replaced it with a new JPEG. If it hasn't been 24 hours, customers will most likely be looking at that old JPEG. You can change the default TTL settings for specific objects using headers such as max-age, expires. Cache invalidation is another thing to consider. If you want to make sure that the users see the new object, but the cache has not expired, you can immediately expire the TTL. But if you invalidate frequently, this could be a cumbersome process and a costly one as well, as you are going to be billed per invalidation. Instead, it is recommended to give the objects a version number. You modify your application to point to the new version, and when the request is made the second time, the new object will be given. SSL is very relevant in CloudFront as well. HTTPS is a protocol between servers that uses SSL. This protocol ensures that the data being exchanged between two servers is encrypted. There is symmetric encryption and asymmetric encryption. When it comes to symmetric encryption, the client is just the computer that the user of the application is using. The client is going to encrypt the data with its symmetric key, then it's going to send that data along with the symmetric key to the server. The objective is that once the server gets the data, it will decrypt the data with the symmetric key that it also received from the client. But the hacker can sniff the key and decrypt that data while it's being sent from the client to the server. This is a limitation of symmetric encryption. We need to have a solution that ensures that the symmetric key of the client gets to the server without the hacker getting a hold of it. So there's asymmetric encryption. The hacker is trying to sniff the data as usual. The client has a symmetric key that can encrypt and decrypt the data. This symmetric key can only decrypt data that it encrypted. On the other hand, we have the server who has a public key to encrypt the data, which can only be decrypted by the server's private key. To begin, the client will send a hello to the server. The server will respond by sending its public key to the client. The hacker might sniff this public key. The client will use the public key it received from the server to decrypt and send its symmetric key to the server. The hacker sniffs the encrypted symmetric key but can't decrypt it since he doesn't have the private key of the server. The server receives the encrypted symmetric key and decrypts it. Now, if the client wants to send data, it encrypts it with the symmetric key and sends it to the server. The server will decrypt it with the symmetric key that it received earlier. When the server wants to send data, it encrypts it with the symmetric key and the client decrypts it. But let's paint another scenario. Let's imagine that the hacker is pretending to be the server. The hacker somehow manages to direct the HTTPS request that was intended for the actual server to himself. Of course, the client doesn't suspect anything since it's using the HTTPS protocol. So as usual, communication is started with a client hello. The server sends the SSL certificate, which contains the server's public key, to the client. This is where a certificate authority is helpful. The SSL cert contains who signed that cert. The hacker's SSL cert is self-signed, which means it's not reliable because it's not signed by a certificate authority. Certificate authorities use their private keys to sign the SSL certificate. The client's browser has the public key from the trusted certificate authority. The client uses the certificate authority's public key to extract the server's public key. And then the client uses the server's extracted public key to decrypt the symmetric key and sends it to the server. The server receives the encrypted symmetric key and decrypts it using its public key. Now, if the client wants to send data, it encrypts it with the symmetric key and sends the data to the server. The server decrypts it with the symmetric key that it received earlier. When the server wants to send data, it encrypts it with the symmetric key and the client decrypts it. So ACM is the certificate authority of AWS. You can only get a certificate from ACM for AWS managed services like application load balancers, CloudFront, but not EC2. If the origin is an EC2 or an on-premise server, then the ACM cannot provide a cert, so you must get it from a different certificate authority. Typically, ACM certificates must be granted in the same region as the service you are using, but since CloudFront is a global service, you can only get a certificate only in US East 1 for CloudFront. You need a public SSL, not a self-signed SSL, for both connections from the client or the viewer to the edge location and from the edge location to the origin. CloudFront by default provides SSL. Back in the day, servers could only host one domain name when using SSL. To clarify what SNI does, we need to understand a few things. Let's say you have two domain names, abc.com and 123.com, using the same IP. If a request is made to abc.com, in order for the request to get sent to the correct domain, the host header in HTTP is used at layer 7. the request can be sent. Now in the same scenario, let's assume that both sites have an SSL certificate. When the request is made, SSL is handled at layer 4. However, since they're using host header, that's only visible on layer 7 and not layer 4. The result is that two websites or two domain names using SSL cannot use the same IP. SNI fixes this, however, by allowing for the domain name to be specified during the client hello. If you choose to have your own domain name at the edge location, such as cdn.mywebsite.com, you must get an SSL certificate. By adding your domain name along with the default CloudFront name you chose not to use, you now have two domain names with SSL on the same edge server. Older browsers don't recognize SNI, so if you want to allow them to use HTTPS, you must use a dedicated IP, which costs around $600 a month. The last thing we're going to discuss is the global accelerator. Now we must be clear that the global accelerator is not a cache. The request from the client will go to the edge location and might go through some hops using the public internet. But from the edge location to the destination, the request will go through the AWS global network, which has less hops. Some things that we should point out is that it does not cache anything, nor does it provide pre-signed URLs. It uses TCP, UDP, and does not have HTTPS configurations. And all the edge locations use Anycast IP, which basically allows the same IP to be used by multiple servers. Well, that concludes the video. I hope you enjoyed it. If you have any concerns or questions, please leave them down below in the comments. Until next time.